Hello everyone, welcome to CS240's Lab 5 video. And in this lab, we are going to be starting on a new part of the lecture, and we are going to be working with Verilog from this lab forwards. And in this lab, we need you guys to download two different programs or environments. And let's start with the first one, which is Xilinx ISE design. And we're using this version of it, which is basically the latest version of it. And it's not getting any more updates, so you won't be seeing any further versions from this one on. And we have this installation guide that will be available on LMS. And what we want you guys to do is just individually install Xilinx ASE on your computers and then start your lab. I mean, you're going to be installing Xilinx ASE and then also the virtual FPGA, and then you can start your labs. And just so you guys know, you're going to need 16 gigabytes of empty disk space, and you need to click on this link, which I already have. I'm going to show you in a second, and then you're going to just follow these photos and these guides basically to download the program. And let me just go on the website. Okay, when you open that link, you're going to be let me see, you may not be able to see that screen. Okay, yeah, I think you can see now. Okay, after you click on that link, you're going to be on this website, and what you need to just check is that you're on ISE archive. That's I am selecting right now, and you're going to be choosing this one. Don't choose this one because this one does something else, so just have this one. And what you're going to choose is for macOS, we don't have the option, but we have a Windows and Linux options, and those are, let me see which one those are. If you go down a little bit, you can see that the installer for Linux is this one. You just need to click on this to download it. And for Windows 10, Windows 7, Windows 8, you need to download this one. And just see that they are very large files, so make sure you have the space and make sure you have a fast internet, or you just need to download it as early as you can so you can start your labs. And I'm just going to click on this one. It will probably, yeah, it goes into the sign in page. Let me quickly try and sign in. Okay, after you log in or create a new account from that page, you'll be directly forwarded to this page. And what you guys need to do is just fill out these data as you need to. And you can just write OzU University for company name and for address. It will be fine. We always do it that way. So, and you need to just fill these ones and say choose student, and then click download, and then you will be able to download the file that's 6 something gigabytes. As you can see here, it's 6.2 gigabytes. I'm gonna stop that and maybe check the PDF if I need to show you something else. Yes, I do. Let me share the PDF file again. Okay, after you download those files, and by the way, for Mac, for Apple products, you need to install a virtual machine before you can set up your Xilinx ASE design, because Xilinx ASE design is not available for Mac devices, so you just need to download a virtual machine, and then set up a Windows virtual machine on that VirtualBox program basically. Let me see if I can um, suggest you some apps. We have this VirtualBox program, and I would suggest using that one, which is basically the best one to my perspective. And we also have used Bootcamp before, but I would suggest VirtualBox more than Bootcamp itself. So you can use either of them, and you can use other ones as well. But VirtualBox works well, so I don't really suggest the other ones because I don't know if they are not exactly suitable for what we're going to be doing in the lab. So VirtualBox would be better. And if you are having any difficulties with Mac, just let us know and we can help you via a office hour meeting on Zoom or something. Make sure you tell us in advance, so tell us early on so we can help you out, so you can do your own labs. And okay, after downloading these, you need to set up the program, and we have this video that we found online that tells you how to set it up. Let me silence that. It tells you how to download and how to set it up basically. And as we have said, you can watch the video in the below link up to 3 minutes and 57 seconds. And from then on, it goes on to the bug fixes and stuff. And this is the most usual bug fix that you should be doing. Just follow this forum link right here to do this one. And if you are having trouble with this one, if you see something like this, please go to this link and then do these basically. And for the licensing part, for this Xilinx AC design, you're going to need to license your program, and you can get your own license from the website itself. And it tells you how to do it in this YouTube video in minute 7, and it tells you you need to choose which license from the website, and you can do it using that. Let me see real quick the video for a moment. I'm not showing you the video, you can check it on YouTube. It shows you how to use the license file again, how to apply it. And okay, yes, I think that should be enough for you guys to make Xilinx AC design work on your computers. If you have any issues with it, just let us know, we can help you out. Okay guys, for this part you're going to need to also download virtual FPGA that Buğra Önal has made with Demirhan 7. And you can see here that to be able to use this one for Windows, you're going to need to download WSL, and you can see how to install that one from this link. And if you follow these installation steps up to step 5 and including that step 5, you can easily install it. And let me maybe click on the link to show you. Let me share my screen, and I think you can see it. And okay, when you click on this link, you will be forwarded to this website, and you're going to be just doing these ones, and you can basically just open a PowerShell as administrator. How to open a PowerShell? You can just search it on your search bar on Windows 10, to find PowerShell. Just write PowerShell and you will see it. And you need to run it as administrator. And you can just run this line, and you can also copy the line directly using this button to paste it on PowerShell. Just run this line and then check the requirements and just basically do these steps, including the step 5. And in step 6, you don't need to do the step 6. Just go back to the PDF file that we have sent you. Let me share that PDF file again. Okay, when after you finish step 5, you need to go to this link, which I already have. I'm going to show you in a second, and you will be seeing the Buğra Önal's Qt Virtual FPGA repo basically, and you will be able to download the newest version from there. And let me show you the GitHub page. Okay, when you click on the link, you will be basically forwarded to this web page. Hold on, let me check really quick. Okay, it will automatically forward you to the releases page. But if you wanted to go onto the link on your own, you can just find the Qt Virtual FPGA repo and then click on the releases part to go to that same place again. And in the PDF file, we just have this version 0.1, but right now we have version 1.1.2. So you can just basically download the virtual FPGA using this one. And for Windows WSL setup, you can just head here. And when you click on this link, you will be forwarded to this drive folder. And you just need to download these files to make it work. You need to follow the PDF again to install these ones, basically. And you're going to be using this one to open your virtual FPGA, basically, on Windows. And for Mac, let me check the PDF before I do anything else. In part 2 of the PDF, you have macOS installation, and you just need to follow those commands on the terminal. Let me show you the PDF. Okay, for Windows, you just need to download these files, and just so you guys know, this tar file's name may change after you download it. Just rename it to this one manually, and then do the rest of the setup. You just need to do these, and you may need to allow Xming through your firewall. You just go on to the command, not the command, control panel to allow it through your firewall. You can Google how to allow a program through your firewall if you're having issues with it. And when you run VFPGA.bat, you should be able to see the virtual FPGA GUI. And if you're not, you may be doing some step wrong, or you may have some other issues. You can just let us know. And for macOS, you just need to follow these commands to make it work. However, for macOS, since you're going to be using Xilinx, and to use that, you need a virtual FPGA, and Windows on the you need VirtualBox, and you need Windows on it. You can maybe try to download virtual FPGA on that VirtualBox, but you can download it on your macOS as well. You can try both ways. If it's not working, you can just let us know so we can maybe work something out. After you do these, you should be able to run your virtual FPGA. And for Linux, you can again just click on this link to be able to install very later. And then you need to install CMake, and then just install CMake using these instructions, these commands. Hold on, I clicked on this link. And okay, after that one you need to install Boost as well. Just use this command on the terminal to install it. And you need to also install this one using this link, and you can just basically follow these instructions to download that one and be able to run virtual FPGA on Linux. And to be able to use it, you need to just basically follow these instructions. And let me maybe run virtual FPGA on my own desktop so you can see. Okay, maybe I can share my whole screen so you can see it completely. Okay, after you download it from your Windows, download from the drive for your Windows, you will have these files, and you can just click on this one twice to run your virtual FPGA. You should be able to see this command window. Don't close it, don't do anything to it. If you need to run some code on this one, and you will need to run it. And just before we go on, these rectangles right here are basically representations of LEDs, and these ones are 7 segments, and these ones are basically switches, and these ones are buttons. And to be able to run a code, you need to specify where these codes are. You just need to go on File, Open, and then you need to add files using that one. And maybe I have these ones here. Let me check where I have my Verilog files. I have this rotating node file, and run your and add your codes basically here using this add button. And then for the top wrapper, you need to click on this one, and maybe not click on it, but click on browse, and then choose your rotating dot wrapper and add it there, and then you click done, and you basically need to click start, and in a few seconds it should be able to run basically. Let's see. Okay, you can see how the command window is printing out some messages. Just ignore those ones, but you can see basically how the rotating dot basically shifts the LED to the right and then goes back to the leftmost one. That's basically what you need to do for the part 1 of this lab basically. So to stop the simulation, you can click on this one, and if you have designed it in a way, you can use these buttons and switches in your design as well. So these buttons also will work, or these switches. And basically that's how virtual FPGA works. If needed, we may also make another video on it sometime soon if it is needed, but I think it should be pretty straightforward for you guys. And if you have any issues, you just let us know on Piazza or via email. You can configure various settings from options settings. Let me see. You don't really need to change these ones because these labs are designed to basically work in the same way. So don't even change these ones because it's not that important for you guys. Let me see. Okay, and if you click on this one, you can see the version. If there is an update, we will let you know, and you can update it using the update.bat, or for macOS or for Linux, we will let you know how to update the virtual machine for virtual FPGA. And basically it for virtual FPGA, you should be able to use it. And by the way, you can basically, let me remove these ones. You can add some examples in, let me see where. Okay, this was my initial folder. Okay, if you go on to Word, you have this example basically, and you can just choose those ones to try and see if it works. Let's see, let's click on this one. Okay, maybe it's running the old code. Maybe I need to restart it if there is some sort of an issue with it. Clicking on this one and then choosing UDC and then clicking browse to add the top wrapper and then done and then start. Okay, ignore these. Okay, these LEDs also work again. I thought it wouldn't. You can see that the 7 segment is counting from 9 to 0, and the LEDs also count in binary format as well again. You can basically see that the virtual FPGA would work if you try with that code before you even start your lab. And basically that's it for this virtual FPGA installation part. After you're done with Xilinx ASE and virtual FPGA and setting them all up, you can start the Lab05 handout. And in this handout, we basically have, I mean, we have 4 pages, but it's not completely filled with tasks. It's filled with a lot of pictures that you're going to be looking at to make your labs easier. And in this part, we are going to be just creating the rotating dot and synthesizing it and running it on virtual FPGA. And we already have given you a rotating dot Verilog file and also the rotating dot wrapper file. And what we're going to be doing is we're going to complete this Verilog file on Xilinx ASE design and synthesize it and have a look at the warnings, and then we're going to be opening the virtual FPGA and running the rotating dot using also this Verilog file, and we're going to see that it's going to work on this GUI. And we have this link here that you can see and do this code basically. And let's start with it, and let me go, let me share my whole screen before I do that. Okay, I think it should be fine. I've already copied the contents of this lab to a new temporary folder on desktop, and I seem to create a shortcut. And what we have here is the Verilog files that we've sent you. We've uploaded on LMS, and the handout and these installation guides. And for this part, we're going to be working on these ones, and we will not even change this one. We will just work on this one. And you can see the files that we've given you, and this part is just given to you, so you don't touch this one, don't do anything with the wrapper file, and also these wrapper files as well. Don't change these ones, just work on the rotating dot and the Night Rider for the other parts. And let's start by opening a new project and including this rotating dot Verilog file on Xilinx. And let me just open IC Design Suite, and after doing that, I already have this other project, but we're going to be opening a new project, and we're going to be choosing the temporary folder that I've created for this lab, and I'm going to create another folder just to make things more clear, and you should probably do the same as well. I'm going to open a new folder. This means open a new folder for the non-Turkish people, and after creating a new folder, I just renamed it Lab05, and then I'm clicking on OK to choose that folder, and then I'm going to be naming that file as, let me see, what should I name it? Okay, rotating dots, since this part is that one. Dot. And do not change anything else on this one, just these ones and this one. And then we press next, and then make sure these choices are as this, basically Spartan 3E, XE3S, 100E, and these ones as well. And don't change anything here if these are the same. And you press next and then finish, and you can see that we have opened this new project here, and it has no Verilog files or other files included in it. And what we're going to be doing is that, let me show you the folder first. Okay, we created this Xilinx project here, and we have our Verilog file here. We're going to be including that file using this one. I don't generally use this one because this one copies that file, like it copies this file into here. But if you choose add source, it probably uses just this file, and if you change this file, it will change the data in the lines inside this one as well. So I try to make a copy of it so that I don't lose my progress whenever I need a new I need changes. And then I basically choose add copy of source, and then go to desktop temporary file that I have. You should probably have a CS240 and then CS240 folder, and then have your Lab1, Lab2, Lab3 folders separately. That would be a good practice for you guys. And then I'm going to choose this Verilog file, and I'm going to open it, and then press OK. And you should be able to see that the rotating.v is going to be here. And I can just click twice on this one to open it up, and you can see that we have our code here, but it's not complete. We just need to write 2 lines here and here to complete our designs. And for this design, for rotating dot, what we need is actually rotating dot means basically for this design we have 8 LEDs, as you can see here, 7 to 0, including the 7 and 0. And this counterpart is basically a delay mechanism that will slow down the shifting of the LEDs. Let me show you what I mean. Okay, if we start by since we will have 8 LEDs, let me have basically indices for the LEDs. Consider these ones the indices of the LEDs, and if we have by default the LEDs like this, and I mean the zeros here are basically LEDs are off, that's what they mean. And if it is 1, the LED is on basically. And rotating dot means at every iteration our LED, the LED that's on gets shifted by 1 when our counter is when our counter reaches the count value, which is 3F in hexadecimal. And after each iteration, it shifts the turned on LED to the right, and basically after another iteration it will look like this, and then it will look like this, and then so on and so on, and then it will get to basically here. And then after this one though, if we shift it right again one more time, what happens is that all of the LEDs would be turned off. However, we don't do that. We change that and we turn on the LED in the leftmost side, and then again it keeps shifting it to the right over and over again. Like it goes back to this state, basically these states. And basically that's what we want for the rotating dot design. And I'm sure you're already familiar with Verilog files and how to code in Verilog, how to program in Verilog. And if you can see the design here, we have our registers here, and what we need to do in our always at star block is that we need to assign values to these variables. And you can see that we have our if here and our else if here and our else here. And normally in most of the Verilog files you will see that we have a data out next, data out, and counter next plus 1, or maybe just counter. And if we had this here, you wouldn't need to have this one here. Basically it would be basically unnecessary, but you can still write that there. It's a good practice anyway. But I'm gonna go back and have it as this one. And okay, we need to write the 2 lines in each of these blocks here. And for the reset, we need these values. We need the default values of these ones. And what we're going to be doing is basically assign values to them. Okay, by default, our counter should be 0. However, our data out next shouldn't be 0 because we need to have an LED on by default, and our default state should be basically this one with the LED on the leftmost side turned on. So how do we do this? We just basically need this one assigned as this one, but in Verilog we don't do it like this one, but we can basically write binary digits. And how we do that is basically like this. What this means is that we have 8 bits, we should have 8 bits here, and it should be in the following data should be the following numbers should be written in binary format. However, you could actually technically do it like this one. I'm writing it in command, but if it wasn't, you could just basically write it in hexadecimal as well. And in that case, it would just basically be 8 and 0. And you can see that this one corresponds to 8, and this one, let me select it properly, this one corresponds to 0. And you can again write it in decimal as well. You would have D here, and then you would write the decimal value of it. And this is pretty much it for our default values. And here we need to also carry out the shifting part. As I've explained here, we need to shift them when the counter reaches the count. And let me write data out next and counter next first. Okay, when the counter reaches count value, which is 3F, we need to reset the counter back to 0. So this should be like this. And after this line, basically, it's going to, since counter next will make counter 0 at posage clock, counter will be 0, and our program will not go into this block and will go into this one and increase the counter one by one again, and then go back to this one and shift it. That's basically how our counter and how the slowing down mechanism works. And in this line, we need to do our shifting. And how we do it is we need to establish a binary array would be a best way to say it. And how we do that is using these these brackets basically. And how we normally would do it is basically if we were to write these ones one by one and we were using any other variables, we could basically write 1b0 and 1b and so on. And this would be like the 7th LED would be turned off, but the 6th one would be turned on, and so on. But here, instead of these ones, we can use variables, and what we do here is we need to use our pre-data out state to our advantage, and we shift the pre-existing state to make it like this. And what we do here is basically, since we're going to be shifting by one, we can basically leave a 0 here for the 7th LED and then shift these ones to these parts, this part, and then when we have this state already, we can shift these 7 LEDs again to make it these ones, and then again we would shift these ones to these ones basically. So I can basically write data out here, and using these brackets I can specify which indices, which LEDs I want there. And since these are 7 to 1, the LED is 7 to 1, I can basically write it like this. If I wanted just one LED, I could just write it this way, but if I want an array of LEDs, I can write it like this. However, after this line is run, after it goes to this state, what it will do is basically it will copy this one to here. However, it will write 0 to here. This is an undesired operation, so we need to find a way to get the 1 back to here. And basically how we can actually do it is we can trick the data out next to have our value back. Since our value is here, we need to copy it to here. But then again, if you have a look at here, it's already 0 here, so you can actually copy it from there to here, and from here to here, and from here to here. So you can see the pattern here. You can copy the data out 0, the 0th LED, to 7th LED. So what we do is data out 0. I think this should be pretty clear for you guys. If it is not, you can ask via email or on Piazza. And what we do here is basically this. And then you can save your code by clicking on this button. I just press Ctrl S, so it's not it's completely grayed out right now. But if I were to change something to be available, you can press Ctrl S again. And then after you complete your code, you need to synthesize it. You can just click here twice, or you can click this button right here, but this button does this operation and this operation together. So you can basically try and click this one twice to synthesize your code, because this is not necessary for the lab. So I'm gonna click it twice to run it. As you can see, it's being run. And in our console, there will be multiple lines of code, multiple lines of output printed. And you don't need to check everything in here, but if it's, you should check if the process is completed successfully. If it is not completed successfully, you should be able to see an X mark instead of this exclamation point. And since we have this exclamation point, if you had an X here, like this symbol, there will be errors in your code. So maybe, for example, if you didn't have this semicolon here, you would have this error basically. If you try to synthesize it, it would get an X here, as you can see. And the errors would be given to you like here, and you know that which line the error is. It says on line 21, there is an unexpected token which is counter next, and it's right here. However, sometimes it can miss the semicolons and say it's the next line, so you need to check it out. But usually it's the correct line that's missing. That has an error. So okay, if you add the semicolon there and then synthesize it again, you will not get any errors if you write it like this. But since we have this exclamation point here, we know that we have some warnings, and you need to check out this tab here. And you can see that we have these delays which are ignored for synthesis. If you have any other warnings, they may be important. You need to check them out and try to eliminate them. You shouldn't have those errors, those warnings. But if you have these delays ignored for synthesis lines, what this means is that on line 13 and on line 14, like here, the delay is basically these ones. If I didn't have those ones here, if I synthesize it, it wouldn't have those warnings here either. Let me show you how it would happen. And you would get this tick here, tick mark here. But you don't need to touch these ones. It's important that they are there. They are for simulation purposes. But you will get these delays ignored for synthesis warnings. Just ignore them. They are fine. They are trivial warnings that we have explained here, basically. These are the trivial warnings that we need. Okay, and also what we wanted you guys to do is to take a screenshot of the successful synthesis, the whole screen. What you need to do is you need to take a screenshot of this screen, this whole screen, and I tend to use this light shot program, which is pretty useful for me. But if you don't have that, you can just press print screen button and then save it on a paint file. If I can show you, you can save it on a paint file and then save it as a PNG or something. But if you have an app that is like this one, that is like Lightshot, it should be pretty useful for you. And I'm gonna click on print screen, and in Lightshot it's going to gray out your screen a little bit, and then you need to select your area, which should be the whole screen. Make sure you select the whole screen. I'm not entirely sure if you can see my Lightshot screen, but you need to save the screenshot using Control C or that button that has the small logo like this button right here. Make sure you include the whole screen. We need to see these delays, these warnings, and this synthesize button, and your code as well, these ones. And make sure you screenshot the whole screen. It's important. And after this one, after your synthesis is done, you need to run your code, your Verilog code on virtual FPGA. And for this part, what we do is we open our virtual FPGA using the VFPGA path, or if you're using it on Linux or Mac, you would know how to run it. And it's explained in this guide as well, so you would know what to do. Okay, my wrapper is in here in this folder, but my rotating dot is going to be here. So let me add those to my virtual FPGA. Let me check if you can see my whole screen. You can. Okay, I'm going to click on File and Open, and I'm going to, you don't need to click on this part all the time, but I'm doing it just to make sure. Click on Add, and then find your folder. You can go on Computer and go on Media, no, go on Mount, and then go on C, which is the C folder, C disk on your Windows machine. And let me see, there should be users here. Okay, and then you need to click on your own user and then go on desktop and go on Lab05 folder. And since we're adding our Verilog file, I need to go on my Xilinx project and choose that file and then click on open. And I need to also include my top wrapper. I'm going to click on browse and then go back two folders, since I have two folders here, and I'm going to choose my wrapper, and I'm going to click on open, and then I'm going to click on done, and I'm going to click on start, and it's going to take a little bit of time, but it's going to run in a few short seconds. Let's wait for it. Okay, by default you will have these LEDs here, and if you click on this button, let me check if it is actually that button to make sure. Okay, it says click here to reset, so it should be that button. So if I click on this one, you should be able to see this one, how the LED is going to shift and go back to the leftmost one. And after you do this part, you can stop the code, and if you want, you can close your VFPGA, virtual FPGA. And after you do this part, let me see if there's anything important that I need to go over. Okay, this one goes over how to include your Verilog files and the wrapper file, and you're going to reset. You're going to press on the reset button, and then you will see your LEDs lighting up. And after that part, after you do that, you're going to be done for part 1, and you can move on to part 2. For the next part and the part 3, we are going to be working on a Night Rider program, Night Rider design, and you're going to be working on the nightrider.v file that we've given you, and you're going to use the Night Rider wrapper v file in part 3 to run your Night Rider code on virtual FPGA, and you can basically follow these instructions to run the code on virtual FPGA as well. This is pretty much like the rotating nut one, except the LEDs are going to behave in a different way. Let me see if I'm sharing my whole screen. I am, so I can show you the notepad and explain to you how the Night Rider should work. Okay, consider you have 8 LEDs again, and our leftmost LED is turned on again. And much like rotating dot, Night Rider will shift the LED to the right and keep shifting it to the right. And then it will get to, and the turned on LED will be the rightmost one in some time. And from this point on, what we want you to do is design the Night Rider in a way that it will behave like this. It will not turn this LED on, however, it will turn this LED on. It will start going to the left. It will start turning this one, and then this one, and then this one. And what this will do is basically this one, and then let me copy it over and then show you. It will light up this LED and so on, and then it will again get to this state, which should be the initial state, and after it gets to this stage, it's going to go back and do these again, and then it will get to this stage and it will do this again, and then it will loop around completely. And that's basically what we want you to design in nightrider.v file. And we want you to again take a screenshot of the successful synthesis with the warnings. And let me show you the nightrider v file. Again, don't touch these wrapper files. Just work on this file for part 2 and 3. You're not going to change anything on part 3 though. And what we want you guys to do is just write your code here and here. And I mean, we've basically given you that we need 3 lines here, and if you check out the rotating nut, what we've written in rotating nut, you would basically understand what you should write in these lines and also in these lines as well. And you shouldn't need to include any other variables. They're not exactly variables, but I'm saying variables to make it easier for you to understand. You're going to write some more lines here, and we said as many lines as necessary because some of you may choose to write it in a shorter way, but some of you may choose to write it in a way that's going to take many lines. So we didn't specify any lines. So you're going to write your code here and here, and then you're going to, and by the way, to write your code, you're going to be going on this start button and then opening a new project in your Lab05 folder that is right here, and you're going to create a new Night Rider project. And I'm saying you need to create a new project because if you keep working on your rotating that file, you're going to probably use the progress you've made on the previous part. So make sure you open a new project so you don't lose your progress. And it's best practice because you may need to go back after some time to these files and work on them. And you're going to create a new project and then click on next and next and finish. And then you're going to again add your Night Rider file that should be here. And then you're going to open it up and then you're going to write your code in this Xilinx AC program. And then you're going to click on synthesize. And as you can see, there are some warnings here, and if you design your codes, I think these warnings should go. However, if they do not go, if they stay, just let us know. We can try and help you out. And after you write your code, you're going to open your virtual FPGA again and run your code there. Let me find the virtual FPGA. Okay, it's turning on. And after you find your code, let me show you how it should work. It's in some other folder that's going to be here. It's Night Rider V and our top one, which should be in this folder, which is Night Rider wrapper, which we've given you, which is on LMS. And I'm just going to click on start and wait for it to turn on. And again, this reset button is the rightmost button right here. So you can press on this one to reset the LEDs, and we need to do that. And you can see it should basically work like this. It should go to the leftmost LED and then go back to the rightmost LED. That's how it should work. How the Night Rider should work in part 2. And part 3, these are the same designs. And after you're done with this one, just make sure you have taken a screenshot of the synthesis as well, the whole screen again. And you can, after you do these parts, you can move on to the modified Night Rider one. And in this part, we haven't given you a default file. You're going to be working on the Night Rider V file that we've given you, and you're going to rename it as Night Rider Part 4. And again, you shouldn't work on that file in the same project. You should open a new project and name it Night Rider Part 4 and open this new project and then add copy of source to add Night Rider V. Can I rename the files? I can't rename it right here, but you can rename it when you're going to submit. What we want you guys to do is we want you guys to rename this one to make it part 4, because in our part 4 wrapper we have this initialization name. This makes it usable for us, makes the design usable for virtual FPGA. So just rename it and then add your codes here. Design your new Night Rider, modified Night Rider, so that it will do something else. And let me see if we've explained what to do on that part. Okay, we've explained what to do with this part, and I'm going to explain you using the notepad that I have already here. And we have in this part we have two smaller Night Riders that will light up from left and right, and then they will meet in the middle and then go back to their respective corners. What's going to happen in this part is we have the leftmost and the rightmost LEDs turned on, and then it will go like this and this, and then it will go like this and this, and then it will also go like this. But when they meet in the middle, they are going to start going back. So it's basically going to be like this, and then this, and then this again. It's going to basically go inwards and then go outwards, and then go inwards and go outwards, and when it gets to this stage, it's going to repeat this cycle. It's going to be basically like this, this. It's going to go inwards and then go outwards, inwards, outwards, inwards, outwards. And that's what we want in this modified Night Rider. Let me make confusion on your parts. After you do this part, you need to also add these designs, add this design and the wrapper file to the virtual FPGA and run it to see if it works. And if it doesn't, you should modify it to make it work. And let me show you how it should look like. Let me add the solution that I already have. I tried in part 4 and the top wrapper for part 4. And I'm going to click on start to simulate it, and in a few seconds it should be able to run. And again, we're going to press on this reset button after it runs. Okay, after clicking on this one, you can see how it basically works. And as I've said, it starts on the left and rightmost ones and then goes in and then goes out. That's basically what we want you to do in part 4. And after you're done with these labs, you're going to submit these files. These are the variable designs that you will have done in these parts, and these PNG files are the synthesis screenshots that I mentioned, the successful synthesis screenshots of the whole screen, including these warnings and this tick or exclamation mark and all of this screen basically. It doesn't have to be a PNG file, it could be a JPEG file, it could be some other picture format. It doesn't really matter as long as we can open it. And I think that's about it for this lab. You will be done after you do part 4. And thank you for doing this lab. Thank you for watching this video. and see you in the next lab.